all I have started with, you can see at the top, I have this 3-axis mill demo. It's a SOLIDWORKS part file. And I don't have any toolpath with it yet. I don't have anything that I've started yet. We're just going to start from the beginning and work our way through as if we're programming it. Just like in the standalone version, you'll see a lot of similarities. Now, in SOLIDWORKS, you can see up at the top left, we have our feature tree. If I were to create a sketch or a 3D model here in SOLIDWORKS, I can go over from that to my different tabs, and we have the CAM manager, which is the exact same thing as our CAM tree in the standalone version of BobCAD. You can see here in the CAM tree, I can right-click on CAM defaults, and we go to a new job. I select what type of job type we offer in the plugin for SOLIDWORKS. We offer the same kind of job types as in the standalone version. We have our milling job type, turning, mill turn. Wire EDM is a bit newer in the plugin. I think a few years ago we added that in. And under milling, we also offer machining for laser, plasma, and water jet machines as well. So I'm just going to stick with the milling job type and stick with the BC3X mill. That stands for BobCAD 3-axis milling machine. And that is going to output a FNUC-based G-code with the post processor for that one. So I'm going to go to the top and hit this green check mark to click OK to go to the next page, which is going to start our stock wizard. And you can see from the first page, we are selecting our workpiece. So I'm defining my finished 3D model here. We'll be able to see a little bit later on why that's beneficial in the simulation. We can make sure everything is cut to size before we run it on the machine by defining our workpiece here. And then our next page is our stock specification, the stock wizard. And up at the top, we have the same types of stock types: rectangular, cylindrical. I can extrude it from wireframe, select an existing solid model, an STL file, or we can revolve a shape around to create our original stock that we're starting with. Now I'm going to go back to rectangle, and you can see I can type in my length, width, and height here. Right now it's at millimeter. Just like in the standalone version, I can go to the bottom right here in SOLIDWORKS and change it to inch once I'm out of this stock wizard page. What else do we have? When we are defining any kind of geometry, so like if we go into wireframe or if we go into the solid model to define as our stock, I can go right here to the feature tree, you can see, and I can select anything here from SOLIDWORKS to define as my solid for the stock type, or when I'm going into like creating a 2-axis profile milling operation, I can select that sketch to do a profile operation right here from the feature tree. So you can see that BobCAM for SOLIDWORKS is fully integrated in the SOLIDWORKS CAD software. So I've got my rectangle stock type. I go to my next page where I'm setting up my machine setup. This is where I'm defining my work offset at. It's right here at the bottom left corner of the stock on top of the part here. If I am not able to touch off there with my tool to set as my G54 work offset, I can change it right here in BobCAM for SOLIDWORKS under the machine setup page. We go here to pick origin, and let's say I'm at the top left corner of the stock right here. I click on that corner, and that would be my new G54 location. And we can also pick from an existing user coordinate system. Just like you can create a coordinate system in SOLIDWORKS, and you can define that as your machine setup. You can also define your machine setup right here in the same way you're creating a coordinate system in SOLIDWORKS. You can click on the origin location. So let's flip the part over and click on it right here. And then I can set, just like in the coordinate system in SOLIDWORKS, I can highlight x-axis, click on a point or a line parallel in the x direction. I can highlight y-axis, click on a point or a line parallel to the y-axis, click on the z-axis, click on a point or a line parallel to the z-axis here. And if it is flipped, you can always click on this reverse direction to reverse the direction so that the z-axis is pointed up, and we could do a drilling operation on the bottom side of the part now, for example. I'm going to go back here to the top of my part. We're going to be machining and drilling the holes from the top here. So I'm going to go back to pick origin. I'm going to highlight the bar under pick origin here and click on this bottom left corner of the stock. And I'm just going to reverse my X and Y directions until I get it pointing correctly there. And then I'm going to scroll down and, well, the OK button's not at the bottom. It's up at the top here. That's probably the biggest difference I've seen so far with the plugin BobCAM for SolidWorks and the standalone version. There's no OK button down at the bottom. You have your green check mark and your red X, just like in SolidWorks for OK and cancel. So I click OK, and then I can go into my milling operations. Now, I'm going to stop here, and I'm going to save the SolidWorks part file. So it's going to save the 3D geometry, the SolidWorks part file, the actual geometry in the file, and then it's going to save everything here in the CAM tree with the toolpath and everything like that inside of this SolidWorks part file. You can also work in SolidWorks assembly files as well. So it can be really helpful if you're loading in the geometry of your fixture and things like that. You can make sure the tool avoids any collisions with that as well. I'm also going to pause here because in case you don't see, say you've downloaded and installed BobCAM for SolidWorks, you open up SolidWorks and you don't see the tab for the CAM tree up at the top here, and you don't see the tab for BobCAM up at the top here. I don't know if you can see any part above that on my screen, but if let's make this smaller for you for a second. So if you see the gear icon right here, there's a drop down next to it, and you can go to add-ins. So this third option down, add-ins, you can click on, and there is a page here for all of the different plugins that is downloaded that you can open or close in SolidWorks. So down at the bottom, you can see BobCAM for SolidWorks. I can make it active with the green check, or with the check mark on the left-hand side, and on the right-hand side, there's a check box to open when SolidWorks starts up. So I make sure both of those checkboxes are checked so that when I open SolidWorks, I've got my CAM tree, I can start a new job and work from there. So from the CAM tree, I right-click on Machine Setup 1, go to Mill. We'll go through all of the milling operations, but again, you're going to see the same workflow and the same kind of layout as you would see in the CAM tree in the standalone version. I get a lot of customers ask me, well, which would be better? If I have SolidWorks, should I get the plugin or should I get the standalone version? A couple of different benefits in case you were wondering. With the plugin for SolidWorks, if your employee or you yourself, you're going to be designing the part file and then programming it all in one software program, then the plugin for SolidWorks could be really beneficial. You don't have to, save it as a SolidWorks part file, open it in BobCAD, save it as a BobCAD file, and then go through the workflow in that CAD software package. You can do it that way. But I also suggest this to other customers that have a design team, and then they have the machinists that program the parts after the part has been designed. So that way you can basically freeing up a license of SolidWorks with that. So you've got one employee who's designing the part files like this here, and then once it's created, they can send the SolidWorks part file over to the machining side of it, and the machining team, or the guys at the machine shop, if you will open up BobCAD, be able to open up the SolidWorks part file, and be able to program with that part file while the design team is still designing in SolidWorks. So it really depends on what kind of facility you have there. We've got a lot of companies that do both. So I'm going to right-click on Machine Setup 1, And we can see all of our milling operations. Down here we have drilling and tapping and our counterbore milling operations. Below that we have mill facing, so we can face off the top of the stock. I'm going to skip that page and we're just going to go right to mill 2 axis. So mill 2 axis offers a profile roughing and a finish pass, pocket, facing, engraving, chamfer mill, corner rounding, all the basic 2.5 axis machining operations, where the tool is going to come down in Z, it's going to move around in X and Y, and then it's going to come back up in Z. So it's not 3 axes simultaneous, it's only moving in 2 axes at the same time. Then we get to our mill 3 axis. I right click on machine setup 1, I go to mill 3 axis, select my geometry. Now the rule of thumb with our standalone version and with the plugin for SOLIDWORKS here is in mill 2 axis we're selecting a sketch or we're selecting surface edges. In mill 3 axis with selecting our geometry we are selecting the full 3D model, and then below that we are selecting a boundary to contain the toolpath inside of a certain area, like inside of this mold. And the reason why we select the full 3D model is because if there was a boss on top here, for example, or any other geometry we need to make sure to avoid, we're selecting the 3D model so that the plugin BobCAM for SOLIDWORKS understands and avoids any collisions. So I'm going to define a boundary next. I can click on these surface edges individually here around the bottle shape. I'm going to right click in the selected items here on the left hand side and clear my selections. And I can right click on one of these edges. And down at the bottom here we have select tangency and select loop. Select tangency isn't going to do a whole lot because it's going to just select the edges tangent to this edge I've selected, which is just the arc that is tangent to. These two edges aren't tangent in any way there. And if I right click and go to the next option, select loop, it will give me the option if I want to select the loop from this edge going around on the top of this surface, the top surface here where my cursor is, or if I click on this arrow, it will change to chain select around this surface down into the bottle. So whatever this surface edge is shared, I can select the chain selection of any of the surfaces that it's touching that surface edge I've selected. So I'm doing this one here. I'm going to make sure the boundary is around the full bottle shape and click OK. Next page, we have our clearance plane, our rapid plane, 200 thou above the stock. It'll wrap it across to the start location, feed down into the material, 100 thou above the stock, and then my top of feature. Since I haven't machined anything yet, I'm starting my top of feature at Z0. If, say, for example, I faced off the first 15 thou already, I could set this as negative 15 thou for my top of feature in reference to the work offset. Then my next page, I have all of my different 3-axis milling operations. I'm going to delete out the 2 in the current operations list here and go over on the right-hand side and take a look at all of our 3-axis milling operations. Now, the 3-axis standard and the 3-axis pro, they are both inside of this mill 3-axis wizard. And the first 6 are in the 3-axis standard. We have our Z-level rough, our Z-level finish, planar, just going back and forth across the surfaces, spiral, radial, and plunge rough. So it'll plunge the end mill down to rough it out. These first 6 operations I almost never use, to be quite honest. About 99% of the time I use all of the milling operations below that. And the reason is because in your standard you have your Z-level rough, in your 3-axis pro you have your advanced rough. So same kind of operation, just a little bit more involved, more options to optimize your toolpath with that one. Just like in the standard we have Z-level finish, in the pro we have advanced Z-level finish. In the standard we have planar, in the pro we have advanced planar. And then we have our other 3-axis pro finish operations like flatlands, where the software will detect all of the flat areas on the part, mill those out with a flat end mill. Equidistant for a spiral toolpath to start from the outside of your boundary and offset to the center, giving us a better surface finish. Pencil to mill any fillets, and project curves where I can project a 2D shape onto a 3D surface to do a 3D engraving operation. So I'm going to highlight Advanced Rough, add it over, and then I'm going to add an Advanced Planar and add that over. Go to my next page. We can set our different work offset numbers. If I'm setting it anything other than G54, I can set it G55, 56, and so on. My next page, we have our standard UI, which stands for standard user interface or advanced user interface. If I open up that parameter page, it's just a different method of how to select your geometry, your 2D containment for the boundary. We have rest roughing and things like that we'll get into with the standard user interface. Probably one of my favorite options in the advanced user interface here is going from your step over. You can calculate it based on your desired cusp height. So we're going to get into the simulation a little bit later and see what our roughing and finish pass is going to do, machining out the stock, and we're going to be able to view how much material is remaining, deviation based on the workpiece that we defined. Now in this one, there's not really any guesswork involved. You don't have to go into simulation, see if there's if it's a tight enough tolerance level for us. We can just type in the tolerance level here. Let's say our desired cusp height or scallop height here is 1 thou. I'll type in 1 thou here, and it will calculate the specific step over we need to get down to that specific tolerance level. So again, we don't have to guess on a step over, go into simulation, make sure it's cut to size. If it's not cut to size, come back, change the step over, tweak those numbers. We don't have to do that. We just let the software calculate it for us here. I'm going to cancel out of this, and we'll just get into the standard UI for today. And our next page, we can set up our tool. So I'm gonna just type in, we're starting as a 1/2-inch ball end mill. I'm going to go into the tool library and change that. So I'm going to go to the top, go to Tool Crib, and go to the tool library down at the bottom. I normally sort by diameter here so that I can easily find, it'll sort the tools if I just click on diameter. And it'll start with the 3-inch face mill, going all the way down to 1/32 inch end mill. These are all preloaded in the software program. And you can highlight one and modify it here, add or delete any tools that you don't need. But then what I normally do, because this is a little bit of a different tool library than in the older versions, usually the tool library was on a separate page, so I normally highlight a tool from the tool library, click OK, then it adds into my tool crib automatically. You can see, although I highlighted the 1/2-inch flat end mill and click OK, I think now it gives us that error message saying you didn't select it from the tool crib. So it just goes back to the 1/2-inch ball end mill. If I'm just curious because I can't remember what that error message is normally. If I select the 1/2-inch flat end mill and just click OK from the tool library, it says the last selected tools were in the tool library. Would you like the tool added to the tool crib? So now it comes back with this error message now. Instead of having to get this error message every time, what I normally do is I will go to my tool library. I've got my 1/2-inch flat end mill, and you could click on this arrow to add it into the tool crib. I have just made it a habit to drag and drop the tool from the library to the tool crib, make sure it's the right tool, and click OK. I can type in my spindle RPM, my cutting feed rate, my plunge feed rate down at the bottom here, or I can calculate it using system feeds and speeds. And so if I hit finish, and if I go to my material library, that's found down under the stock here in the CAM tree. So if I click on this arrow to expand the stock options there, we have our material library that I can open. And so whether I'm machining from carbon steel, aluminum, different types of plastic, we have different feeds and speeds for each material type set here automatically. We can add a group, we can double click on one of these material types, change the surface feet per minute, the chip load per flute, and we can define it based on what tool type we're using as well, whether we're machining with a carbide tool, insert tool, high-speed steel. We have different categories there as well. So I go back to the feature, go back to the tool page. Now it is set up for my spindle RPM, cutting feed rate for cast aluminum as my material type. And then my next page is my cut pattern. And yeah, again, I'm just going to reiterate that you can see it's the same window and it's the same exact workflow as you would be used to in the standalone version of BobCAD. And the workflow here with the milling, going to be the same workflow with the turning, mill turn, and wire EDM machining. All the same pages to set it up. You're just inside of the SOLIDWORKS CAD software program. So we've got our cut pattern. Offset out, start from the center, work our way out. Offset from the side walls, work our way towards the center of the pocket. Parallel, which is zigzag back and forth inside of the pocket. And we have our high-speed machining options, our morph spiral, and our adaptive roughing, where the tool is going to start at the center, continually spiral its way out, keeping constant tool engagement the whole time. We'll do that one. And normally, when you set an adaptive toolpath like that, you're setting a larger depth of cut. Let's do 150. Setting a smaller step over, so we're taking out tiny chunks, but at a lower depth of cut there. Let's do 50 thou for the step over, I guess. Let's set, what else do we have on this page here? We have our allowance down at the bottom right corner. So we're leaving a certain amount of material for the finish pass to clean up. One thing that I'm noticing right now for the plugin for BobCAM for SolidWorks is normally in SolidWorks, it only goes out to 2 decimal places. So you can see with this allowance, it's only set to 10. Even when I change it to 15 and go off of it, it's still only showing 10. So you'll see it either round up or normally round down these numbers actually. You will want to make sure that your numbers are precise here. You can do that by going down to the bottom left. You're not able to see the bottom left corner of my screen because I'm in the way. There we go. So down at the very bottom left corner here, you have where it says IPS, or if you're in millimeters, it's mmgs. Down at the bottom, you can see Edit Document Units. You can click that button, and with this checkbox, I change the units here and change the decimal places. I think it's the length here, the very first one, you change to 3 decimal places. You can change the angle to 3 decimal places or any other number in here as well. But I think it's just the first one I need to change to 3 decimal places so that we have our allowance to 15 thou there. It can be very useful to do 3 decimal places, maybe 4 or 5, depending on the tool size and depending on the depth of cut and step over, things like that. And then we go to our next page. We can plunge, ramp, or spiral into the center of the stock here. We can also, if there was an opening to the stock here, let's say the bottle shape right here, there was an opening to it, I can uncheck this box center cutting tool, and that would calculate the tool path so that the tool would start from the outside of the stock out here and work its way in with the side of the tool as a side roughing routine rather than plunging the tool down in. But there's no opening for this one, so I'm going to spiral around. Next page, we have rest roughing. So if I had a previous roughing operation, let's say I used a 1-inch diameter tool to rough out as much material as I possibly could, I could type in the previous tool diameter and corner radius here, and the software will calculate any areas the previous tool couldn't fit into and calculate just that tool path here. So it would start right where we left off from the previous roughing operation and avoid any air cutting that way. I'm going to move myself over again here. So we've got our rest roughing option. Going to turn that off. We have our machine flatlands option. So if there were any flats down at the bottom of the part, it would come back with an additional operation to mill any of those areas out as well. Linking for each step over. Our gauge check page to make sure the tool and the tool holder avoids the work piece here. And again, we could also load our fixture in as an assembly, all of the components to our machine to make sure the tool avoids any collisions at the machine here. Then we have our advanced feed rate page. If we're not able to set a rapid rate at the controller, we can convert the rapid moves to feed moves to set that rate. And we can also set the feed rate for where it's linking between groups of geometry. And we also have an adaptive feed rate. I really like this option here. The standard will just do the cutting feed rate of 89 inches per minute. If I change it to adaptive or radial chip thinning, we can set a minimum and a maximum feed rate here. And for example, when the tool is getting into larger material at a time, like into these corners where my cursor is located right here, if the tool is getting into larger material at a time per tooth of the tool, the software will calculate how slow the tool needs to move to keep a constant chip load, and that can reduce chattering at the machine. So by default, it sets it to 10% up to 150%. So 10% here means 10% of the cutting feed rate that I have set here of 89 inches per minute. So it would print different feed rates at each line of code anywhere between 8.9 inches per minute up to 89 inches per minute, up to a max feed rate of 150, whatever 150% of 89 inches per minute is. And then, so that's if you're going on the outside corners here and there's less material to be removed per tooth, it'll actually speed up the feed rate as well. Then our last page is MDI. That stands for manual data input. If there were any various G or M codes in here that we wanted to add into the G code manually, we could do that here in the feature. We can also add, let's see, what options are there? There's feed rate, spindle speed, different work offset. You can also just go here to raw text. So what I normally do is I highlight raw text, click on before or after tool change. I'm going to highlight before tool change, and I'm going to click this add command button right here. It adds this text box here. It says you can enter anything you want here. I'm just going to type in test comment. And with the raw text button clicked, it's just going to print that line of code before the tool change. If I click on comment, it will add parentheses before and after the text that I added here. Next page is asking if I want to do the standard UI or the advanced UI for my advanced planer operation. I'm going to do the standard UI again. Next, I'm setting up the tool. It's starting at a 1/2 inch ball end mill. You can see that I can type in basic calculator functions. So if I type in plus, minus, multiply, divide, I'm going to type in a backslash here to divide by 2 to make it a 1/4 inch, and divide by 2, 1/4 inch ball end mill here. We've got our system feeds and speeds that I'll leave alone for now, and we go to our next page. Our cut pattern, zig would be one directional cutting, zigzag back and forth. These up and down options I don't use very often. I've had a couple customers try these out, but up will start from the bottom of the stock and work its way up to the top of the stock that we're machining. Down will start from the top of the stock and work its way down, sort of overlapping in the middle here with this toolpath. Kind of interesting. So I'll do zigzag. I normally don't do the optimal machining angle. Sometimes it's not optimal for me, I find, so I just normally uncheck that, and then I just manually type in the lace angle that I want. Now this is the angle direction of the cut of the planer toolpath. So 90 degrees will go back and forth along the y-axis. If I set it to 0, it'll do a horizontal cut back and forth across the x-axis, and I can do anything between 0 and 360. For example, if I set it to 45, it'll do a 45-degree angle diagonal across the part here. If you have questions on this number here, I think our developers do a lot when it comes to trigonometry in terms of the numbers that they have here. So like with this one, 0 is at the 3 o'clock position, like in trigonometry, and then it goes counterclockwise. So if you see a lot of numbers like this that have to do with angle amounts, more times than not, it's going to be 0 degrees is the positive x direction, and you go counterclockwise from there. 90 degrees is the positive y direction, 180 is the negative x direction, 270 excuse me, 270 is the negative y direction, 360 all the way around. So I'm going to leave this at 90. I can set my start corner of the position here and go to my next page. I have my standard step over amount of 100 thou. So it's just going to go 100 thousandths above the across the part here. If I change it to adaptive, this is an option in the advanced planer, and we can set a step over. So it'll just go 100 thou across these flats here, for example, with this example part here. With the minimum step over, it will calculate anywhere between the minimum step over I set here, let's say 10 thou, up to 100 thou, in the tight corners here to clear out as much material as possible. So in the advanced planer, you don't have to do one planer operation with 100 thou step over, come back with an additional planer toolpath with a smaller step over in the tight corners. It'll give you that variable step over rate there. You also have a perpendicular option. I don't tend to use this very much, but you can set when it goes around a cylindrical surface like this to go perpendicular to that surface. I usually use adaptive. Leaving 0 for my allowance for the finish pass to clean up. We can plunge, ramp, spiral into the material, entering into the stock. We're only plunging down in 15 thou, so I don't see a huge need for that. Next page, we have options for our rest finishing. So just like the rest roughing, it'll pick up the previous tool and machine anything that's left over. Limits, if I wanted to, so center of tool will end the tool path where the center of the tool ends at the edge of the boundary. I could contain the tool path inside of the boundary. So it'll compensate for the tool, stay inside, or compensate for the tool and go to the outside and machine any areas outside of the boundary as well. We also have our cutting extents. So the center line of the tool will end at the edge of the boundary. You can see with this example, there would be some areas remaining here that haven't been machined. That's why I like this 3D extents option, where the tool radius will end at the edge of the boundary, and part bottom, where the tool can go along the side walls and mill those out as well. I normally leave it at 3D extents. Next, we have linking for each step over, our gauge check page, our advanced feed rates, and our MDI page, just like before. I'm going to hit compute. It'll take a couple minutes to compute this toolpath. So while that's computing, if anybody has any questions, more than happy to answer them. Haven't gotten anything so far. But if you guys do have any questions, please let me know in the comments section. I'm more than happy to answer anything that you have when it comes to the milling process that we've just done, or anything else in the plugin for SOLIDWORKS today. Alrighty, so we can see the toolpath here. All of the green and pink lines right here is the roughing operation with the adaptive roughing. And we'll take a look and see how that looks, and then we'll get into drilling the different hole sizes here. So up at the top, you can see the simulation button. I click on that. I think you can see it. If not, you can also right-click on milling job and simulate as well. We can just show the workpiece in the stock here. and we can hit run. Up at the top here, you can see the length mode. It's telling me how long the distance traveled to machine out this part. It will take about 2,400 inches of tool travel. If I change it here at the top left from length mode to NC mode, it'll tell me 208,000 lines of code. If I change it to time mode, it tells me it will take about 16.5 minutes to do the adaptive roughing here and then the planar toolpath. And again, it's only doing one directional cutting. So if you wanted to climb mill in this like we're doing here, you can certainly do that, or you could zigzag back and forth and save even more time. All right, so we've got the roughing almost done. And the planar toolpath going back and forth across the surfaces here. If I wanted to see it again, I can just go to previous op, play through it a little bit slower here. Oops. So just going back and forth across the surfaces. Once that's done, now down at the bottom right, you can see here once I move myself again. All right, so down at the bottom right corner here, there's this yellow tab labeled Analysis. I can open up that tab, I can click on the drop down and go to Deviation, the fourth one down. I can load different colors once I hit refresh here. It'll load different colors on the stock depending on how much material is remaining to get down to the workpiece I've defined. Now you can see here, everything in green is cut to size with a cut tolerance over here. You can see a plus or minus 8 thou. The next color up, this really light blue teal color, anywhere between 8 thou and 26 thou remaining along these ridges here. If I go into the corners, it's anywhere between 26 thou and 45 thou remaining in the corners here. You look at the holes, the dark blue color is anywhere between 64 thou or more remaining because we haven't drilled the holes out yet. But this is a great verification tool to make sure everything is cut to size before we run it on the machine. If we go around a profile and the tool is too large to fit into any corner, it'll show us here that there's still material remaining because we weren't able to get into the corner. But this one's great. Let's close out of it. We can set a smaller step over and take a look at that. Just double click on the feature. Go to my parameters page in the advanced planar. Make the step over down to like, well, let's do 20 thou. So anywhere between 10 and 20 thou. And hit compute. All right, and then next we've got our drilling operations that we can do. Now in the older versions, we could right click on machine setup 1, go to mill drill hole, select our geometry, select the holes of the same sizes here, do the feature for the 1/2 inch holes here, compute it, then go into the next feature, do the next size holes, keep going so far and so forth. I can right click on machine setup 1 now, and we have this hole recognition page. So it's the third option down here, hole recognition. I click on the solid model and click OK. No holes were found. Uh-oh. Maybe I can, let's try it again. Nope, let me try the solid model here. If I go to hole recognition, drop down the feature tree, you know what? I think it's having issues because it was imported just recently. So let's go in because it's just 2 features anyway, 1/2 inch holes, 1/4 inch holes. If we were to drill the holes by going to mill drill hole, I'll go here to mill drill hole, select my geometry, select the 1/2 inch holes again. You can select either the top surface edge, the bottom surface edge, or the sleeves of the holes. I normally select the sleeves of the holes so that it picks up the depth right here automatically. If you don't, you can always go to pick bottom and pick the bottom edge of the hole here. If it's a through hole, you can just pick the bottom edge of the part. and click OK. 2 inches, and it's a through hole. Something that I really like in the drilling operations here is, say for example, well, I'll get into that with the 4 holes. That's actually a better topic to have. But here, you can set your top of feature, your feature depth. It's a through hole. We're going to our next page. We can do a center drill and a drill for this here. Chamfer drill and chamfer milling operations. We also have reaming and boring operations for the holes. Our next page, our sorting order. So the most optimized way, we can pick the order manually or set it in an X or a Y direction if there needs to be a certain way that you need to sort the order there. If there's a clamp in between here or something, you can sort it a different way. Set our work offset number. Set our tool type for the center drill. Set the plunge feed rate. Set a dwell time for all of my drilling operations. Next page, we can set the depth for the center drill. We can do a single depth peck or fast peck down into the material for all of our drilling operations. We also have pecking for the tapping operations now as well. So we have peck tapping also built right into the software program. Pretty convenient. Then we'll go to our next page. We have our MDI page for manual data input. Next page, I can set up the tool. It already brings in a 1/2 inch tool for me, so I don't have to change it. Next, we've got our plunge feed rate. We've got our depth. So you can see up at the top, we have our effective depth at 2 and 50 thousandths. So it adds 50 thousandths because it is a through hole. So BobCAD understands that, makes sure to go an extra 50 thou to break through the bottom of the part. And overall depth is an extra 150 thousandths. So you can see this example here from the effective depth to the overall depth is an extra 150. And the reason for that, you can see, is because of the tool shape. With the tool angle, the angle of the drill, it's adding an extra 150 thou to make sure that the drill breaks through completely past the bottom of the part. If I go to my drill page, the tool page again, and change that point angle, this number 2 setting here, of a different angle, it will calculate the overall depth according to the angle I typed in there. So that's where that number comes from. Then we've got a peck, fast peck option here, and MDI page. I'll hit compute. We have the drilling with these 2 holes. Let's do the drilling for the next 4 holes. I'm going to right-click on Machine Setup 1, Mill Drill Hole. Normally, I'm saving a lot more frequently than this, but this is just a sample file, and I'm basically, I've got all of this programmed already before. So, but I tend to save pretty frequently. Every minute or two, I'll be hitting save for the SolidWorks part file here. But next, I go select my geometry. I'm going to select the sleeves of the holes because it should pick it up. Should pick up the depth here. If I go to the left, you can see point and arc usage I can use as bottom. So it will pick up the depth if I select that option here. Oh, maybe not. What the heck is going on? I think it was a step file when I brought this in, and it's having some issues with the step file with the geometry selection with the surfaces. I think I have to save it again as a SolidWorks part file and reopen it. It's not like in the step file. So anyways, get the depth of 2 inches here again from the bottom of the part. It's a through hole. Now, I'll go through the group retracts option. So right now, this is one group of holes, all 4 of them highlighted. You can't see that, so I'm going to move myself again. So you can see all 4 of these pink dots here. These are the 4 highlighted holes in one group right here in this geometry selection page. Down at the bottom, you can see these buttons, break hole group and regroup holes. So I'm going to break hole group, And now I can highlight each one, and they're all individually in a group of their own. So this first one, group 1.1, is the top right hole. Group 1.2 is the bottom right hole. Group 1.3 is the bottom left hole, and group 1.4 is the top left hole. And I believe I can rename them too, so it's not group 1.1, 1.2. But anyways, let's say I want to sort them, the top holes and the bottom holes. So there's group 1.4, the top left hole, and the top right hole I want to group together. So I've got the top right hole highlighted. I'm going to hold Control on my keyboard and click on that bottom one so that it's the top left hole and the top right hole both highlighted. And I'm going to regroup holes. And I'm going to do the same thing for these two here. I'm going to hold Control and click for the second one. Holding Control and clicking is to individually add. If I wanted to, let's say, click on the top one here and add all of the ones in between the first one and the next one I click, I can hold Shift and click. It'll select all between all of them. But if you're individually adding, you can click on one, hold Control, click on the next, and regroup the holes. I'm going to name, instead of group 1.2, it's going to be bottom holes. And group 1.1, I'm going to name top holes. So now we can see that. Cool. Now, between the two groups, between the top holes here and between the bottom holes here, let's say there was a clamp in between there that I needed to retract high enough to clear. At the top, that's what this group retracts option is for. So I'm going to change the height here. Let's change it to 5 inches and click OK. This plane option is for anything with 2.5 axis or 3 axis milling. If I change it to cylinder, it's for 4 axis for a rotary table. Sphere would be for 4 or 5 axis machining. So I'm going to plane, and it's going to be the Z axis, and I'm going to click OK. I'm going to do a center drill and a drill again. And that's about it. I'm just going to hit compute. And now you can see when I backplot it, I'm going to right click on the drill operation down at the bottom of the cam tree here and go to backplot. Starts up here, comes down, drills it, goes across, only at 100, what is this, 100 thou? Feeds over? I think it's going to wrap it over 200 thou across. So it's rapiding over 200 thou across, coming down 100 thou, drilling, coming back up. Now it's going to rapid to the 5-inch location to clear that clamp here, so that instead of having to retract that 5 inches between all of the holes, it's just going to retract at that location between the two groups. That's what the group retracts is for. So instead of retracting, wasting time, 5 inches at every hole, you're just doing it at the one location you need to clear across the clamp here, and then come down 200 thousandths, feed down into the material, drill, wrap it across at 200 thousandths, start feeding at 100 thousandths, and drill. There we go. So that's what the group retracts is for. Can be really useful for holes, and you need to set a separate clearance plane from the regular clearance plane at just one specific location, or maybe a couple. If you're drilling many holes like this, you can it would be really beneficial. So after that, we'll simulate. We'll right-click on the milling job, go to simulation. We'll see the 20 thou step over of the planer toolpath and make sure that that is cut to size, and we'll take a look at the drilling operations as well. But yeah, again, just to reiterate, all of these things that you see, all the settings, parameters that you're seeing, same thing and same workflow as if you were using the standalone version. So if you were to use the standalone version and you want to get the plugin for SolidWorks or vice versa, there's not really a learning curve to it. So that's one of the best benefits of going from the plugin to the standalone, or for the standalone over to V12 here, BobCAM for SolidWorks. So here's the roughing, here's the finish pass, looks a lot cleaner. We'll take a look at it in the verification, the deviation report after this, once we get into the drilling operation here. So I slowed it down a bit. Planar toolpath is done. Does the center drill. Switches to the 1/2 inch drill. And then we'll do the 1/4 inch drill after that. So once everything looks good, close out a simulation. We go to the CAM tree here, and we can right-click on the milling job and go to Post. It'll generate the G-code here in my posting window. And you can see all of the G-code here. I normally hold Control and use the scroll wheel to make it larger so that I can see it a little better. And I can see the percent sign, the comments, the safety line of code here, and then the comments before it gets to the first tool, G54, XY move with the spindle speed call out, and then your height and diameter for your compensation of the tool, and all of those settings from there. We can tab over again to the CAM tree, that's down at the bottom from our posting page, to be able to modify the milling job again. If you needed to do any more modifications, then you can just hit simulation to simulate, and then post to post the G-code. And then you can right-click in the posting window once it pops up. Right-click in this window, and you can save it, put it onto a flash drive, and send it over to the controller from there. We also have the NC editor in our BobCAM for SolidWorks. That'll open up, and that will allow you to modify the G-code if you need to, and be able to see exactly what you're looking for. Everything's color-coded in here to modify it a little bit easier. We also offer, this is in the NC Editor Pro, not really something I was necessarily thinking of going over today, but we can simulate in NC Editor. Now the simulation in NC Editor is in the NC Editor Pro, but what this is doing is it's actually reading the G-code line by line and backplotting the toolpath that way. So if there were any discrepancies in the G-code, anything incorrect, a Z move that's going to gouge down into the table or something like that, it's going to show you because it's going to read the G-code in this verification. In our simulation in BobCAM for SolidWorks, it's only going to simulate the graphics of the toolpath. This one's actually reading the G-code line by line. So pretty cool stuff. Close out the NC editor. Trying to think of anything else that we're going to be going over today. That was pretty much it. Just seeing the workflow of the of creating the milling operations in BobCAM for SolidWorks, different from the standalone. Basically, the only difference is you're working inside of SolidWorks, and when you're selecting geometry, you can select from the feature tree here and select your specific geometry inside of the SolidWorks part file. If we go into a new file and create our geometry as a sketch or an extrude boss, 3D model, things like that, then we can go to start a new CAM job. We have milling, turning, mill turn, and wire EDM. And again, it's all the same types of things. If we went into turning, go to a new job, select the stock, and go into the turning operations: facing, turning, groove, drilling and tapping. We offer threading, cutoff, and stock handling for a bar feeder. And you can see in the workflow, it's the same kind of workflow as in the standalone, selecting our geometry, deciding whether we're turning on the OD or the ID of the part, setting a roughing and maybe a finish pass afterward, outputting in CAN cycles, defining our tool, and then setting the compensation, the depth of cut, an allowance for the finish pass to clean up, lead in and lead out, and all of those settings, just like in the standalone version. We come out with, I think now actually, we're coming out with all of the versions at the same time. We used to come out with the standalone version in September to line up with IMTS, and we used to have the BobCAM for SolidWorks program here line up with SolidWorks World in February, but we just come out with the same at the same time around September to be able to have everything line up with each other. All of the updates and all of the new tips and tricks, things like that, in the standalone version is also in the BobCAM for SolidWorks version here as well. So if you guys have any questions, please let me know in the comments section. Thank you guys for viewing the live event today, programming in V12 BobCAM for SolidWorks. Hope you guys enjoyed it. Hope you guys learned a few things. And yeah, if you guys have any other questions that you may have had concerns on with the plugin, please let me know. But thank you guys again for viewing the webinar today, and I hope to see you in the next one. We do live events every other Wednesday. So that will be March 5th will be the next one. We don't have the topic at hand yet. We always email our customers and see what they want to see in the next webinar to make sure these are tailored to exactly what you're looking for your live events. And once this is done being live today, it is also going to be on this website in the recorded events as well. So you can always go back to it if you had any questions on the workflow for BobCAM for SolidWorks. All right, I don't have any questions in the comment section. So thank you guys again for viewing the live event today, BobCAM for SolidWorks. We hope to see you in the next one, March 5th at 1 o'clock p.m. Eastern Time. Thank you guys and have a great rest of your day. See ya.